Hi everyone, today I'm going to show you how to calculate Bayesian average curve number for developing any hydrologic model like HEC-SMS or SWOT. We need the curve number grid, and for some other models like HEC-SMS we need the Bayesian average curve number if we use that curve number method. Okay, so I'll develop that curve number grid first from land use and land cover and soil dataset. I already have that. I downloaded this, and if you don't know how to download this dataset, you can watch my previous videos, and I'll give the link in the description below. And once you are done with your data download, you can even crop the dataset based on your study area. So I have this study area located in Massachusetts, USA, and this is kind of DEM data we can see here. I already projected this DEM on using the state plane, that is US 2011 feet system. So I'm just turning off this DEM right now, and you can see the subbasins. I have basically 31 subbasins within this study area, and at the end of this video I'll calculate the basin average curve number. So what we have to do, let's turn on the land use and land cover dataset. So here we have the land use class, water and developed. We have different types of developed land here. Open space, it is developed and low intensity, medium intensity, and high intensity. So we'll even try to simplify the process. And we have some forestry and agricultural land here. So out of this classes, what we have to do, because we can see the red marks, these red marks are basically developed, either it is medium or high intensity. So in order to reduce the complexity, what I can do, I can even reclassify this land use and land cover dataset. Like for all developed, I'll consider this as either developed or residential area, and for water it will be water, and for like forest, there are forest, right? I'll even make all these different types of forest as one. So and we have other vegetation, so I'll use the name as agricultural land. So there will be 4 classes: water, developed or residential area, forest, and agriculture. So we have, if I just open, if right click and open the attribute table, you can see the values. So we have these values, like value 11 is for water, 21 for developed, 22 for developed low intensity, 23 for developed high intensity and medium intensity, and 24 for high intensity. So if we somehow just change this value, then definitely it will be reclassified. And for other land like forest, barren land, we can use those as our, the barren land will be agricultural, and this is yours forest, evergreen forest, mixed forest. This will be renamed as forest. So at first let's finish the land use reclass, and then we'll work on the soil. So for soil data, let me show you the soil information. Here I downloaded this data set, so that is in covering not only this study area, and is covering the other part of the study area. So what you have to do, you have to clip it. So I'll show you how to clip this data set. Basically this soil class, it is feature data. These are all polygons, so we have to clip it using clip function. I'll show you how to do that, and I already have done this clipping by using extraction by mask, because these are a raster. So we'll clip our soil dataset based on the boundary of our study area, and then I'll do some processing, and ultimately I'll convert it to raster. Then we'll combine this land use and soil to compute the curve number. See, if I open this soil information data set, what we need that curve number. Curve number varies from 0 to 100. So 100 for water, perfectly drained, and here we'll see the soil class A, B, C, D, or some classification we'll see A slash B or B slash D or A slash D or C slash D or B slash D, there will be different types of soil class, and there will be some missing data as well. So at first we have to investigate the data set, and then we can process. So let me, this one, see, hydrologic soil group. So we can see V, D, B, D, and then we have missing data set here. So we'll investigate what is the dominant soil type, and based on that soil class, we'll even replace all this missing value. And we don't know, because this data set is covering basically the entire watershed and sub-basin, that is HAC-8. Okay, so this study area boundary is basically covering the HAC-12 boundary according to NHD plus. So I'm turning off this one. Let's work on the land use and land cover. So we have to reclassify this, right? We have 16 classes right now, and from 16 classes we'll reclassify this into 4 classes. So what is the process for reclassification? So I'm going to geoprocessing. So for this thing I'm using ArcGIS Pro, but same thing I did even in ArcMap. It is same, there is no difference, only the option or function looks a little bit different, but the task is almost same. You can repeat that, or if you have any query or question, you can post it there and I'll try to answer that. So at first we have to reclassify. For reclassifying any raster or anything, we have to go to spatial analysis tool, and from that spatial analysis tool we have that reclassify option there. If I go down, and you can see we have the reclassify, right here, the reclass, and inside that reclass we have that reclassify option. If I just double click on that, and if I even use this LULC project raster, because I already projected that one. So here we can see that, okay, we have these unique values 1 2 3 4 for this value we have. This is basically this land use and land cover, but instead of this we have to select the value because we need to change the value, and then I'm clicking again the unique. So now we can see the actual value, and there will be the new value, so we have to change it. By this time we know, right, from the attribute table that 11 is for water, 21, 22, 23, 24, these are basically the developed, right? The open space, low intensity, medium intensity, and high intensity. So what I have to do, I can even manually do that. So for water, it will be like water, the class 1, and there is another one like this 90 and 95. These are basically UD wetland, and we have other like herbivores, right? Herbaceous wetlands. So these wetlands will be water. So that 11 will be 1, that is already there, and for 90 I can replace this as 1, and for 95 this will be 1 as well, and for 21 this will be 2, it is already there. 22 it will be 2, and 23 this will also be 2. 24 this will also be 2, class 2 means developed. And 31 is basically barren land, that is going to be agriculture, so we are going to give agriculture as 4. And 41, that is going to be forest. So for forestry we're giving the number as 3. 42 it is going to be 3 as well, and 43 it is also 3. We are done. So 52 it is going to be like shrub or scrub or mixed forest, so we are giving this as yeah, no, we're already done with this one. For 43 was that mixed forest, and then we have the agricultural land like herbaceous or pasture land. So 52 is that, so it is going to be 4. 71 same thing, 4. 81 it is going to be 4, and then 82 it is going to be 4 as well. So here we can see from this value field we just changed it, right? So 1 is for water, and then developed land will be 222, and then the forestry will be 3, and agriculture will be 4. Now if I run it or if we just click here, run, then it is going to recalculate everything and is going to give us the reclass. And we can see here, see, I'm just turning off the previous field we have. If I zoom in a little bit, and we can see we have these 4 classes, right? So if I right click and open the attribute table, then we can see this is this count 1, but we don't know, right? We have to remember that, okay, this 1 is for water, this 2 is for residential or developed land, this 3 is for forest, and 4 is for agriculture, but I can't even remember, right? So what I can do, I can add another field and I can add the description. So for adding field here, I'm just clicking on add fields. Here I can write LULC, okay, LULC and the types, okay, LULC types, okay, that's okay, no problem. So giving the name as long, the type, the data type will be like text, the description we have here. If I click on save, we're gonna give that name here. So but these names are missing, right? So from the missing name, I can even use a query, or you can even edit it, but I don't want to do that. I already have that like function. I have written this function here. So when the grid code will be 1, it is gonna give us the name of water. When it is 2, we already know that residential or developed, and when it is 3, forest, and for 4, it's gonna give the name as agricultural. So I'm copying this code and I'm right clicking on that and calculate field. So here we have everything there, this type, and it is kind of Python 3 expression for Pro. And here I'm gonna copy and paste that code block. It is there, and I'm calling the function here, and then we have to pass that variable, which will be the value, right? This value, if I double click on that, so this value, on this value is the grid code here. When the grid code is 1, it is going to give us water. Okay, let's can activate enable undo and apply. See, it will done, and it's done there. So it's very efficient way to do this if you have many classification, and if you don't want to do that manually, so you can even use any script and any Python script like this. So that's that. I'm closing this one. So we have this, see, if I open the attribute table, so we have the name and everything. So this is already in a raster format. Okay, so what I can do, I can even export it, like I'm just exporting that, exporting the raster as T file. Okay, I have a location. This location has to be outside of your geodatabase. Okay, so here I know the location there, and I'm just saving it here as LULC. Okay, LULC underscore reclass grid. Okay, so these are basically our land use and land cover reclassified grids. So I'm just saving that, and now I'm exporting it to a file. Okay, just let me change it to the state plane. Everything looks okay, and okay, let me just, maybe the name is not even good. So LULC is okay, and what I can do, reclass. Let's see if it works. Sometimes, otherwise I have to even, maybe this time it is working. Previously the name convention was not that right, so I have it. I'm just removing the previous one, and I have this one. See the types, and if I want to show you the grid code 1 2 3, we can do that. We can go to symbology, there, and instead of these are unique value, and instead of type we can change the type to value. So automatically you can see the value 1 2 3 4. So you already saved that. Okay, so after saving this land reclassification, what do we have to do now? We have to work on the soil data. So I'm just turning this off. So this is my grid. So what I have to do, because if I superimpose my soil information there, we can see this is polygon, right? So each polygon is basically intercepting our land use. So land use is changing for each of this land use, because we know we have that curve number table. If you go to your website and if you search for the curve number table, you will see that this curve number table is basically varying with your land use and soil class. So based on soil class A, B, C, D, it is varying. Okay, so now what I can do, I can even show you that one later on, not a problem. And let's see, we can at first work on our soil dataset. So I'm turning on that, and now what I have to do, I have to clip that based on my study area boundary. So that is the boundary of my study area. If I just put it there, I can see the boundary. Okay, I'm turning on the soil, this land use class. So that is going to be my boundary. I have to clip it. This is basically featured data set. So I'm going to geoprocessing, and from this geoprocessing tool I can go to that analysis tool and then extract, from analysis to extract and clip. Okay, if you just click on that, and map unit will be my input value, map units, and the clip feature will be my basin boundary. So that is going to be my basin boundary, and map unit underscore clip will be my output. Okay, so if I just run it, and it's gonna give us that clip. Let's see if it works. Definitely it should work. It is gonna take a while, like less than a minute or so. Okay, I got it. So I'm turning off my previous extended field map unit, and now we have this soil class for our study area. So if I open the attribute table, and we have to take care of our data set because we have missing data. Let's check that hydrologic soil group, and here we can see A, B, C, D here. See, still for this area we have some missing data, right? So we have to replace, we have many missing data set, and we have to replace that. But before doing that, we need to see which one will be our replaced soil class. So at first I can change the symbology so that we can see which soil type is dominating the study area. So we have like few polygons, so single value and or not single value, we can use unique values, and then I can even select that soil group, hydrologic soil group. There are many, but you have to be able to find that one. Okay, hydrologic soil group, and here we can see the missing value, and if I want to change it, you can change it to something very, very prominent so that you can even see the difference. Okay, so from my understanding I can see that this right kind of this color is basically violet kind of color. This is dominating the study area. So soil class A is gonna be our dominant soil type. So see here we don't have anything. So this is the place where we have missing data. We don't know, so we are gonna replace these locations, this brown color, by A. Okay, so how can you do that? At first we have to select those polygon. So we have that option there, selection by attribute. I'm gonna open that attribute table, and then we have to select that. Okay, I'm gonna, here we have the option select by attributes, and then it's gonna open this window, and we have to select which field. So when that hydrologic soil group will be empty, like this way, I'm selecting this one. So where hydrologic soil group is equal to, if you click there, you can see we have all these things and we have the empty field there. So it's gonna select all those, see. And if you want to see how many we have, so I'm just showing only the selected fields. So these are the number, even huge, not that even, because these polygons are very small. So 1868 fields are missing. So we can even replace, go to that specific field, and we can replace that hydrologic soil group there. Just right click and then calculate field. So everything is okay. And here what we have to do, we have to even replace that by a, it's a kind of string or text, so that's why I'm giving the double quotation. And if I click apply, so it's gonna replace the field, empty field. Okay, so we are done with this one. So we have now, so this is done. And now if you show the entire field, and if you just clear the selection, everything is gone. See, now if I even reclass this one, it is showing this missing thing. So I'm going to symbology, and let's just try to change it for a moment, and let's see if I again change it to that hydrologic soil group. This time it won't show any empty field here. See, it's already done. If I change the color as before, or we can select any color we want like this. Okay, it is gonna work. So A is gonna be our dominance. Okay, it doesn't matter, I can select any color, we have to go for the computation. So now we have our soil classification dataset here, soil class A or D. That means for any specific field or polygon, we have combination of soil class, soil type A and D. So for my understanding, what I can do, because for A class we have a certain number of, we have the specific value of a curve number based on that land use. So if it is like A or A/B, that means what I do, I just try to make average of these two for specific this one and this one. So the curve number for A/D will be the average curve number of A and D, and for this one it will be average of B and D. For C/D it will be the average curve number of C and D, and for C it will be the specific one. But before that we have to identify for any specific cell what will be the land use and what is the soil class. So based on that land use and soil class, we have to find out that specific curve number. So still this soil class is feature, so we have to convert it to raster. And if you want to convert it to raster, you need like number, not like this type of text, right? The computer will understand only the values, the numbers. So let's open again. So we have to even reclassify this one as well, and then we'll convert it to raster. So we'll have a raster of soil classification and land use as well. So then we can even process and we can generate our curve number grid. So at the end of this table, I can add another field, right? And if I add another field, then what I can do, okay, if I add another field, let me just try to, maybe I have that edit is on. I have to save it first because the previous edits are already there. I'm saving, then that field will be activated. I have to add a new field, and this time, okay, let me explain that one first. I'm gonna add the field. Okay, so I'm gonna give A as integer 1, and A/D will be integer 2, and B will be 3, B/D will be 4, 5, 6, 7. So we'll have 7 different number. So based on that number value, because we can remember a is 1 is representing a, 2 is representing this a/d, right? So this is how we'll convert this feature to raster, and then we can combine with our land use raster to compute our curve number grid. So I'm adding a new field there. This will be soil grid or soil code, whatever it is. Okay, soil code, I'm giving the name of the field as like soil underscore code. Okay, and then it's gonna be long or short, it doesn't matter. Okay, I can give it a short integer. That's it. Okay, I'm gonna save it, then we'll have this empty field at the end of the attribute table. Okay, let's check that. If we have, I think it's there, we have generated this one empty field, so we have to fill up this field based on this. So I already told you that, okay, a will be replaced by 1 and a/d will be replaced by 2. So instead of manually selecting, we can do it in 2 different ways. I've written the code already there. I'll show you how to do that within one single click. But if you don't want to write that code, and if you want to even do it one by one, even you can select it this way. Even you can more simplify this one if you want, because you can reclassify this way. A and a/d will be 1, b and b/d will be 2, c and c/d will be 3, and d will be 4. So you will have 4 different soil class instead of 7. But for accuracy, I'm just showing you without simplifying this part. So you can do it in 2 different ways. You can select first a, and if you want to make it as it is, so select where land use and land cover. That will take a lot of time, because we have to select that soil group is equal to what? A. If you want to give it like 1, so it's selected, see, selected. And if you see how many of this cell value will be A, so these are your A, and let's check if it is selecting the A actually. Where is the hydrologic soil group? See, all A's, see, have been selected automatically. So at the end, you can just again right click, and you can replace the way I replaced the missing value, right? Field calculator or calculate field, and you can put with an inverted comma here A, not A, this time it will be 1, right? And for this one, you can select again a/d. You can even give the value 2, or if you want to combine this together, then what you have to do, just cancel this one and change the selection again. So you can even select that way as well. Select by attribute, and again that hydrologic soil group is equal to A. Select this one, add a new clause, and then use OR, and again select that hydrologic soil group. This time will be a/d. Then it will select when it is A and a/d. So it is selecting both, see. And if I show you that how many of these have been selected, we can see and we can check, and here it is, I guess. Okay, here, see, it's selected A and a/d everywhere other than these 2. So now even you can replace these values as 1, right? So I'm not going to do that. I have written a script again, so I'm deselecting everything, and here I have the code. So reclassify soil, and here, see, when the value will be A, it is gonna give us 1. It is a/d gonna give us 2, and so on and so forth. I'm just copying the script, and I'm copying it, and then what I'm gonna do here, I'm just selecting the, I'm deselecting everything. I already got deselected, and at the end I'm right clicking. I'm just right clicking here and then field calculator. Similarly, I have everything there. It's gonna select everything. So again, I'm gonna paste that function I have written, reclassify, copying that name of that function, pasting it here, and which field I'm gonna take that input. So that field, hydrologic soil group. So here, if I just double click on that, it will be our input. So it is going to read, if it is A, it will return the value 1. If it is A/D, it is going to give us 2, and so on and so forth. Okay, so I'm just going to apply it, and it's done, I guess. Let's see if there is no error and nothing. Hopefully, yeah, it finished successfully, and I'm closing it, and see, for this one it is 6, and we have everything. There is no missing value, nothing. So this is our soil code. We have our soil code now, and we can even close that. And here, instead of A, B, C, D, we can even replace, we can even display the value as 1, 2, 3, 4 as well. We're going to symbology, and then we are going to change it from hydrologic soil group to soil code. At the end, we have the soil code now available, and here we can see, and we can see this soil code. So what we have so far, this is still feature, so we have to convert it from feature to raster, because it is possible we have this number. So we have this 1, 2, 3, 4, and then we have this land use reclass, right, as 1, 2, 3, 4. So this is already in raster format. So let me convert this one to raster. So how can I do that? We have to go to geoprocessing tool, and then for converting it to raster, we have that conversion. See, we have the conversion tool, and in this conversion tool we have two raster here. See, if I expand it, and then we can find this polygon to raster, because this is polygon. We can click on that, and our input will be map unit. And before that, what we have to do, we have to check if our coordinate system is same. So I'm not gonna convert it first, because our land use reclass is in state plane. Let me check that coordinate system, right? Otherwise it will be difficult to see. It's already there, NAD 1983 and state plane Massachusetts. Okay, so we have to make sure that this is in same coordinate system. So I think it's in different special reference. Yeah, it's in WGS coordinate system. So let's convert it. Let's project this clip one. Okay, so geoprocessing tool, and from geoprocessing tool I have to go back and then find that projection data management tool. From data management tool you can find that projection and transformation. Since it is a feature, we can use this one, project, and then our input will be map unit clip, this one, and then our output coordinate system is gonna be from the layer. From the layer we can select, expand it, that state plane Massachusetts FIPS, that US feed 2001. I'm selecting this one, and okay, it's there. So input, and that is gonna be our clip. Okay, so map unit clip and the project. So let's run it. After projecting this one, we'll convert it to raster, and that will be the perfect selection we have. So I'm gonna turn off this one. The previous one we have map unit clip, and now we have that projected one. So let's confirm that we are already projected. See, we have the same projection system, this one NAD 1983 and then a state plane. So we are good to go. So again, going to geoprocessing tool, and then from geoprocessing, what you have to do, you have to go to conversion, right? Because we are going to convert from polygon to raster. So click on the polygon, and our input will be map unit project, map unit clip project, but the value field based on which the raster will be generated, it is not the field ID, it's the soil code, right? Soil code, the one we just generated. So this one 1 2 3 4 5 6 7, and output raster. So here there is another one, you have to make sure it is okay, because your cell size should be same as your land use reclass. So confirm that your cell size is also okay. So here we can see that raster information, the cell size is 98.425. I'm copying that and I'm pasting it there. I'm not taking any risks. Okay, any risks. So here it is. Cell size will be this one, and my, okay, I'll specify the output. Okay, let me specify my location output raster here. So that is gonna be our soil, okay, soil grid, okay, soil grid, and it will be this one, soil grid. And here environment, for environment we have to change that snap raster. So that snap raster will be exactly same as LULC reclass. So it is gonna snap the boundary based on that. Okay, so we are done with environments, we're done with our cell size. So the cell size is same as the land use and land cover, and we're gonna assign that value at the center of the cell, the center of the cell, and input is okay. So based on the soil code, let's run. If it works, then definitely we're at the end of our tutorial. So we have a few steps remaining, but the difficult task, we're done with this one. So we have our soil grid. See, we have our soil grid, we have our land use reclass. So I'm turning off my previous field. So we have to combine. So what exactly we have done here? We have our grid, that is soil grid. So this 1 means A, 2 means A/D, 3 means B, 4 means B/D, 5 means C, and then 6 means C/D, and 7 means D. So based on that, I have already generated a table, okay, the curb number table like this. So here we have that land use class, water, medium residential, forest, agriculture. So the land use value is 1 for water, medium residential for 2, forest for 3, and agricultural for 4, right? And hydrologic soil group, I already extracted that one based on this value and A, B, C, D. So here 100 water, 100 for all of this soil class, there is no difference. But for medium residential, if the soil group is A, it is going to be 57. If it is A/D, I just calculated the average between this D, right? At first I calculated this one, I got this value from the table. If you search that hydrologic soil group from US Army Corps of Engineers, they will give you this list. So from the table I just generated this simple table here. So for medium residential, I just tabulated the value for A, B, C, and D. Then in between this I calculated this average, okay, and just made it integer, and same as B/D and C/D. So now we have to figure out how to assign these values. If our grid, if the land use grid, because in this map we can see we're just superimposing these two, right? We're superimposing these two. So we have the same grid. If I zoom in, we have the same grid. So here we have the same grid. What will be the curve number for this one, right? if I just turn this off, yeah, so here what will be the curve number? So it is land use is 4, see, yellow, it is there. So if I turn on, so it is there, it could be 5, this one, right? So how can we assign this value for cell by cell, because we have millions of cells? So the logic we have to apply here, we have to find this value when land use is 1. For land use 1, the value is 100 because it is water. For water, for any type of soil, the curve number, these are basically the curve numbers. Okay, so the value will be 100. For medium residential area, when the land use is 2, land use type is 2, means medium residential or developed, and if the soil class is A, means if the value, the grid value, means it is in raster, so we already assigned that value as 1. So if it is 1 and if land use is 2, it is gonna give us 57, and if land use is 2 and if it is this value is also 2, it is gonna give us 72, and so on and so forth. So it is very hectic. We have to like make the combination of these two, right? We'll have 21 or 22 conditions. So these are conditional statement. So how can I do that? So here what I've done, so in order to do that, I have written another condition here. I have that curve number grid, so it is a very big statement. So I'm going to just copy that, Control A and Control C, and then what I have to do, I have to use the geoprocessing tool, and then from geoprocessing tool, raster calculator, from map algebra we have to go to special analysis tool, and from special analysis tool we have to go to map algebra, and from that raster calculator. And here if I just paste, okay, the condition, but we have to remember that, see, this is soil grid, okay, and this is LULC underscore reclass, but the code I have here, see, it is not, it is LULC underscore code. Either we have to rename those, okay, let me just rename those soil code, Control C, so that it can detect, okay, instead of soil grid. Or what we can do, we can even copy this name, because the function I have is more like general. So I'm copying this one and replacing this name here. So all soil code will be replaced by, okay, search and replace. All soil code will be replaced by this soil underscore grid and replace all, okay. And then for LULC we have to even copy the same thing, and then we have to replace that LULC code. Instead of LULC code we have to replace this by LULC reclass and replace all. So we are done. Now if I just Control A, Control C, copy, and from this geoprocessing tool, means this map algebra and raster calculator, if I just paste it there, okay, it's there, all conditions are there. It's pretty complex condition, so the logic I already described, I followed that one. So output raster, I have to specify here, I'm gonna even give the name of this curve number, okay, curve, giving the long name, curve number grid, okay, that will be my curve number grid. Let's see if this, okay, this name is bad. So what I can do, I can give that CN, okay, CN grid, CN grid, capital, okay, CN grids S, because I have other one, so it is S grids. So if you run it, hopefully it is gonna work, and let's see it will generate that. It will combine the condition. It is going to take a while because it is checking these rasters, and we have pretty nice, see, curve number grid. It's really nice. So if I see, these are the curve number. If I turn off our previous field, soil grid, the individual soil grid we have here, and we have individual land use reclass, we don't need that one, so I'm just turning off. So see, this is the class, means the curve number is varying from 30 to 100. 100 is for water, right, and 30 is for very less. Yeah, so it varies from 0 to 100. So that soil is basically draining very less, right? Okay, so what we have to do now, we have to calculate the average, because this is the boundary of our subbasin. The black line, you can see we have the boundary. So for example, this one is our HEC-SMS model boundary, subbasin boundary. So basically this boundary I've got from HEC-SMS model. So we have to calculate curve number for this subbasin, right? Okay, if I just assign, if I give the name, okay, level, I'm just leveling that one, and you'll see this is the name of the subbasin, and level properties. If I go there, and it's gonna open, and let's see which one I'm gonna give. This one will be the name. Okay, it has subbasin. Oh, not the basin boundary, not the basin boundary. Okay, we need to have our subbasin. So this is the subbasin we need to know. So I'm gonna give the name of the level, and if I just go to leveling properties, and this time we can select the name. It's already there, so the name will be the subbasin name. So I think you can already see that, yeah, it's there, subbasin 7. And if I just make the symbol a little bit bigger, you can see I'm making it as a bold and giving the name as 14 point, and you can see, right, this is my subbasin. So this is one subbasin, this is another subbasin. So what we have to do, we have to be able to compute one single curve number, because this curve number is varying, right? So you can see we have these are basically the gridded curve number, 98.425 feet by 98.425 feet grid. But within one subbasin boundary, we have many grids of different curve number. We have to be able to calculate one, because the model takes one single value for each of these subbasins if your model is lumped model. So how can we calculate this basin average curve number? We have that option. So let's see, we are basically gonna calculate that basin average curve number. Again, I'm gonna go to geoprocessing, because this is the toolbox you can find. Okay, let's see, it's gonna open. I'm going back, and let's go to that special analyst tool, and from there go to journal, and from journal go to journal statistics as table, and here you can see the input raster or feature. So that is going to be our subbasin. And what will be the field? So if you want the name of the file, name of, yeah, if you want to compute the basin average curve number based on the name, right? If I want to show you that attribute table, you can see, because we need the number, curve number based on the name, subbasin 1 2 3 4, and this is how we can assign the value, right, in our model. So 1 2 3 4, we have 31 subbasins here, so we need that. So that's why I have selected here the name based on name. Let me just open it. So I selected input raster or feature zone data. So that is the zone data I have, subbasin boundary, all this boundary, and the zone field will be name, and then the input value raster. So that will be our curve number grids, the grid we just generated after just finishing all this processing, and it is going to give us a table because I selected that, right? And you can even, so we are going to calculate the basin average. Here we have all these options like maximum, minimum, and then other thing. Okay, So let me just calculate all, and from this one we'll even use the mean value or the average value. So that is gonna give us the Bayesian average. Let me just calculate that. So after finishing this one, it is gonna give us a table, separate table as this in journal stat subbasin 2. So I think it's already there. Journal A here, see, it's already selected. So if I open that one, it's gonna give us the value. Then we'll just save this as a Excel file, and you can then copy and paste it. So here, see, subbasin 1, it has that area and the number of count we got, like this one within that subbasin 1, and the minimum value was 3, maximum was 100, and the range is 70, because if you take the difference, it is the range in between the minimum and the maximum, and the mean value, that is the mean value 70.79. So it computed, and it is gonna give us this one. So that is gonna be your Bayesian average curve number for subbasin 1 and for subbasin 2, and so on and so forth. So if I want to save this table as Excel, how can I do that? So again, go to geoprocessing, go back, go to conversion tool, and then here you have that, okay, conversion tool, and then Excel, table to Excel. If you click on that, your input will be that 2, journal stat 2, and it is gonna save this there. Okay, I'm copying the location and running it. Yeah, it's done. Let's check if we have that already. So within this raster curve number grid, within this raster we can find that. So here, let's find the Excel file. Is it there, or where it is? Curve number grid, and in raster it should be there. Okay, let me go back and check it again, because I think I didn't click that. Okay, so it is gonna be there. Okay, it's done, or maybe near it's done. It took a while, I guess. So, oh, it is a curve number and my project. Okay, it's within that my project, and then journal statistics 2. Okay, my project. So you have to go back to that curve number grid and my project, and here the second table, you can check the time. It is this now started. So I'm clicking that, and we have everything there. So here we have everything, but we need the mean, right? So if I want to make it as like integer or this number 2-digit value, yeah, this is our Bayesian average curve number. And if you have your model based on the same subbasin number, even you can use that. So that is the way you can calculate Bayesian average curve number. It is a little bit time consuming and tricky. You need to be able to download this data set, and you have to process it, and then you have to follow sequentially, then you'll be able to do it. Okay, and now if you want to even export this as a map, you have to prepare that layout, and it's there. If you want to even turn off your other fields like study or subbasin boundary, you can do that. Here I'm just turning off my subbasin boundary. Okay, I think I already did it. Let's see, I'm turning off that. It is gonna look pretty well, right? You can add even other scale bar, your north arrow, everything a legend. And then if I just export it, and let's see what we have here. So I'm gonna save it within this one. Okay, so changing the directory. Okay, cn.png. I'm just exporting it, and let's see. Yeah, it's done. See, I think it's done, and we can even, oh, we have even other types. Oh, we have this one. So I'm turning this off because mistakenly I turned that on. And here, okay, let me just change the name again. So CN1, okay, CN1, then it is gonna give us that, this one, curve number grid, map up curve number grid, and you can add the description there as well. So here it is, curve number 1, my project, it was there. Hopefully, let's see where it is. Okay. So we are gonna export. Oh no, we don't. Okay, we are exporting different things. So we have to export our map layout. So this is curve number. We don't want to do that. Curve number 1. We are basically mistakenly exporting this one. We are exporting our map. This one PNG, right? So we are exporting this PNG, and I'm just giving this grid, and now I'm giving this curve number name. Okay, curve number dot png. Mistakenly I exported a different one, the raster. Now it is going to export that map as .png file. So you have to be careful what you are going to export and check before exporting for the final time. So that's it. I think, yeah, after saving that, we can see it pretty quickly, and then we'll finish. So what I've done so far, I started with our land use data set, right? So let's see first, and then we can go back. So here it should be there as PNG file. Okay. Wait a minute. So it should be within this one, curve number. Let me check for the final time. Okay, share, export, where it is. Okay, oh, it is there. Okay, let me copy the directory. It's curve number grid and my project. Curve number grid and my project. Yeah, curve number grid, my project. I have to refresh this one. So that is the demerit of. Okay, so I'm pasting it. Yeah, here it is, CN, and inside that CN we have the .png, and here we can see the map. Yeah, pretty nice map. We have this river network and everything is there. So that's it. So let me just recap everything what I've done so far. I started with land use information data set here, and I just reclassify this one based on the class developed, and then water, forest, and agriculture, and then I clipped my soil data set. These are basically soil sargo data. You can even download that. I'll give the link in the description below. You can download it and you'll get that shape file, and you'll get that hydrologic soil group A, B, and you'll have missing data as well, and you have to replace those missing data after clipping your study area and based on the dominant soil type. And then you have to provide that soil code by using this 1 2 3 4, the integer, and then you have to convert it, you have to project it, and right, yeah, the projection system should be the same. And then you have to convert this feature to raster based on the same cell size, and then you have to write that conditional statement using that map algebra that will even combine these two, and then it will give you that curve number grid. And once you have the curve number grid as raster, you can even convert this raster to basin average curve number value based on your sub-basin. Okay, so that's that. If you have any query or question, you can ask. So thank you again for watching my channel, and thank you for supporting this channel. So stay safe and take care. Bye.